Okay, so today we're going to kind of look at how to simplify tricky rational exponent and radical problems. If you watch some of the other videos, you kind of we go through the rules in those videos, so if you're not familiar with them, you might want to go check them out. But this is a tricky problem when you don't know what to do, but it's not so bad when you do. So let's just kind of put parentheses around this exponent so we realize that this is all an exponent, 5x minus 3. And so we're 2 raised to the 5x minus 3 power. But there's something we've done in the past where we can take this 5x, and this subtraction is actually the quotient rule, right? Because whatever's in the numerator, we have the same bases, we just subtract. So this situation is really just the quotient rule, and we can kind of take it one step further, right? We can say 2 to the 5th power, we can simplify that to 32, and we have it raised to the x power over 8. So here we are, we're kind of at this simplified form. So 32 to the x power divided by 8, and we can kind of simplify it and leave it in this situation since we do not know the value of x. We can't really make a division simple here. So let's look at another one. Alright, well, this looks similar to this, except that we're adding here. Well, this is the quotient rule, right? Quotient rule. So what do we have over here? We have the product rule. Remember, when we add exponents, that means that we can take this base and we can, sorry, not add, but multiply bases with exponents, right? Because this would become this. So it's kind of just working backwards because we have a variable. It's really the easiest way to do it. And so now we're going to multiply. We got 4 squared. What is 4 squared? Of course, that is just 16 to the x power times what? 4 to the 3rd power, which is 64. So if we are going to rearrange this, we end up with this 64 times 16 raised to the x power. And of course, we can't really do anything with this because we see that we can't multiply these two numbers just like we couldn't divide these two numbers simply because, well, we have to raise this first before we can multiply. Alright, this is another example. We will get to that one, but I just kept them covered so we're not distracted. I do have perfect squares over here because it's always good just to kind of think about these when you're dealing with radicals and simplifying them. Which we will see shortly in this example here. So how can we simplify things? So notice that this has a base of 3, 9, 27. Now, over here we had the same bases. And typically we can't do anything if the bases aren't the same unless we can figure out a way to make bases the same. And we can kind of do that here. We can kind of think about this 3 to the 1/2. But then we can take this, this 9, and let's put it into parentheses, right? And outside the parentheses we put this 2. So really what we have is 3 times 3 squared, right? Because that would be the same thing. It'd be 9 squared. Well, we'll put this over this, and we can do the same thing here. We can say 3 times 3 times 3 raised to the 2/3 power. Of course, now we kind of need to distribute. So this would be my next situation. I probably need to kind of go over here. So I'm going to take this up. This is going to kind of go up here, and so I'm going to end up with 3 to the 1/2. Oops, let me erase that, make it cleaner. The fraction 3. I'm just rewriting the first term, the first part of the term. Then I'm going to distribute the 2 to the exponents that are not there because, well, they are there because a 1 is always assumed if it's in there. So I end up with times 3 squared times 3 squared, and I can do the same thing to the denominator, right? I can do 3 times, now I could have simplified this, but I'm just trying to show you what it looks like with bases. So I would have 3 times 2/3 times 3 to the 2/3 times 3 to the 2/3, right? And of course, when we multiply them, we would just add the exponents, right? So we would we'd have 2/3 plus 2/3 plus 2/3, which would give us 6/3, which is just 3 squared, right? So if I kind of break it down, I can bring this whole thing down and I can add the numerator. So I'll show you 3 to the 1/2 plus 2 is in the numerator, and I have 3 to the 2/3 thirds plus 2 thirds plus 2 thirds, right? And because all the denominators are the same, I can just add the numerators, and so I end up with, in my denominator, I end up with 3 to the 6 thirds, which is really just 3 squared. All right, and then in the numerator, I end up with 3, this is 4 and a half, right? So it'd be 4 and a half, but that's not really the neatest way to write it, so let's just do 2 times 4 plus 1. It's an old kind of 6th grade process. So we get 3 to the 9 halves, okay? And so that's what we have there. But now we are back to the quotient rule. And look, I can write right over here since it's saved me some space. And this is kind of a long-winded problem to get to an answer. And there's other ways to do this, but I'm kind of showing you the whole conceptual idea. So I'm going to take it, and this is now going back to the quotient rule. So here we subtracted, so I can take that 3 to the 9 halves, and I can subtract 2. But of course, when we add or subtract fractions, right, we have to have like bases. So I'm going to get this to be 3 to the 9 halves minus 4 halves, which is the same. So we end up with 3 to the 5 over 2 power. And if I want to just write this in radical form, it would look just like this. The base, the power, and the root. Now, I don't need to put a 2 here. And I do need to put a 5 here just because a 2 is always implied. So it would look best if it looked something like this. 3 to the 5th power. Or I can put parentheses around this and put a 5 here. These two things are exactly the same thing. It's just the way we kind of consider them. But remember, this is an exponent here. It looks a little small there, but I just want to make sure you understand that is an exponent. And that is 3 kind of complicated problems. And then we have one more, which looks not as bad, maybe. Depends on how you perceive it. But again, there's this one exponent on this 3. So we want to distribute. Both terms are going to get that 5/3 exponent, so I would end up with 3 1 times 5/3, right? And then that would be this, and then we'd have x 1/2 times 5/3. Okay, put parentheses around it, right? We distribute, and this is the raising the power to a power rule that we talked about. So it doesn't look like we're going to need our perfect squares for these examples, but that's okay. So what do I end up with? I end up with 3 to the 5/3 power, and times x to the 5/6 power, right? I multiply. Now, I can rewrite this in different formats. They don't have the same fractional exponents, so they don't have the same root. So I guess I could add different roots, but that really doesn't make sense in this situation. I don't have to do that. I could, but just so we see what it would look like with roots, I'd have this denominator out here, the base here, and then raised to the 5th power, times the 6 root here, x as the base, and 5 here, right? And so this would be our value. Now, there is a little more we could simplify it, but this is the gist of the idea. You could play around with it to kind of get these under the same radical symbol and manipulate things, but right now that should be enough to kind of guide you in some of these more complex scenarios. So thank you.